the formula for the derivative of inverse function really come in handy when we want to find the derivative of inverse trigonometry functions, such as the derivative of sine inverse of x. So sine inverse of x is the same as arc sine of x. It will give you the angle back. What does it mean? So what's arc sine of x? And give you theta back. It means if you look at a right triangle, and if this angle is theta, okay? So sine of theta equals x. Therefore, arc sine of x is theta. So that's what the relationship means. Okay, it's all about a right triangle. So what it means is opposite of theta is x, and the hypotenuse is 1. In that case, opposite divided by the hypotenuse, x over 1, will give you x. So then, in addition, so what about the adjacent? What is the length of the adjacent side? It is, using the Pythagorean theorem, is 1 square minus x square. Then you take the square root. So then these three sides will satisfy the Pythagorean theorem. So now this is the nature of the inverse sine function. How do we use this knowledge to find the derivative of sine inverse of x? Well, you consider the derivative of inverse function formula. It says if f of x, now in this case is sine of x, and your g of x is the inverse sine function, then according to the formula, g prime of x, so the derivative is just 1 over f prime evaluated at g of x. Now we know what f prime is. Okay, we know the derivative of the sine function. It's just a cosine function. So when you plug in g of x, so f prime of g of x, it's just cosine of sine inverse of x. So if you want to write it that way, okay, so the derivative is 1 over cosine of sine inverse of x. That's completely fine. But we want to see what is equivalent to and make it really simple just in terms of x without all the sines, cosine, and inverse function. So then we have to look at the knowledge or the relationship between sine of x and arc sine of x. Okay, so what is cosine of sine inverse of x? Like I said, the sine inverse of x is an angle. It's going to give you the angle back that will satisfy this relationship. This is what you have, okay? And we extract those information to define a sine and cosine function in terms of x. So now this is really going back to the right triangle and look at the right triangle. So now what is cosine of this angle? What's cosine of theta? Take a look at the triangle. According to the triangle, the cosine is just adjacent. Okay, so what is the adjacent? Is square root of 1 minus x squared divided by the hypotenuse. In this case is 1. So what it's telling you is this cosine of sine inverse of x is really just square root of 1 minus x squared. So in that case, you can replace this expression by just this expression to get the answer. It is 1 over square root of 1 minus x squared. So that is the derivative of sine inverse of x. And you can use the same idea to derive the rest of the inverse trigonometry function, the derivative of all of them. But for the time being, it might be more beneficial if you couldn't really derive it. It's okay, but you must memorize how to get the derivative using the table. Okay, that's the most important thing, because in this class, it's very important that you know how to apply those formulas.